All right, so working on the Chapter 8 review, I think that a good problem to work through would be number 5, this word problem, where we have a differential equation, and we're given that dy dt is proportional to the amount present, ky. And we can separate and integrate, which by now should feel pretty familiar. So dy over y equals k dt. Integrate both sides. Natural log of y, absolute value of y, equals kt plus c. Because the letter y is defined as the amount of substance present, we can drop the absolute value bars. We're not going to have a negative amount of a substance. So exponentiate both sides, and you get y equals c e to the kt using that trick we've used several times where you just drop the c in front. And then we are also told that the half-life is approximately 5,500 years. So let's see what we need to do. Express the decay as a differential equation, did that. Solve for y, did that. Then determine the age of a fossil to the nearest 1,000 years if its radioactive substance has decayed to 20% of the original amount. You might be saying, well, we don't know what C and K are. But what we can say is that when time was 0, we had some initial amount, and it's pretty common to just write it as y0 or y0. And if we substitute that in to our differential equation, we get y0 equals ce to the k times 0. In other words, y0 is equal to c. And then we can use the half-life information. It was told the half-life was 5,500 years, which is our carbon. I think that's pretty close for carbon-14. Don't quote me on that. So that would mean that y of 5,500, because that's t for years, is equal to the initial amount divided by 2. Or you could have written 0.5 or 1/2 of y0. And so substituting that in, what we have is y0 over 2 equals y0 e to the k times 5,500. Divide both sides by y0, and it's gone. And then take the natural log. So the natural log of 1/2 is k times 5,500. 5,500. And then divide by 5,500 to get the k value. The natural log of 1/2 is the same as negative natural log of 2, because 1/2 is 2 to the negative 1 power. And so if we divide that by 5,500, that's going to be our k value. We can put all that back together to answer question C. Determine the age if the radioactive substance has decayed to 20% of the original amount. And so we should get a number bigger than 5,500 because 20% is more decay than half-life. So we have 0.20 times the original amount equals the original amount e to the kt using our k of negative natural log of 2 over 5,500 times t. Now we're going to solve for time. Divide by y0 and take the natural log. So the natural log of 0.20 equals negative natural log of 2 over 5,500 t. And so multiply by 5,500, divide by negative natural log of 2, and that's your t value. I'm going to pause and grab a calculator because I can't do that in my head. Okay, so 5,500 natural log of 0.20 divided by negative natural log of 2. That looks good to me, I believe. Hit enter. Here we go. So we get 12,770, and they asked me to round it to the nearest 1,000 years, so I guess that's 13,000. Make that into a 3. Okay, so 13,000 years. And just a good reasonableness check on your answer is that if something goes through the half-life once, it's at 50%, and another half-life would get you to 25%. So that would be 11,000 years. And so we knew it was a little bit bigger than 11,000 years. This feels pretty reasonable to me. So thanks for watching.